Hello everyone, welcome to channel IGCSE&GCE MATHS School. Today also we are going to discuss some questions of the paper 2H of Mathematics A of Edexcel IGCSE January 2022. Right, okay. Until now we have discussed around 23 questions of this paper. Today we are discussing the question 24. That is a question of kinematics. Kinematics is actually the section of mathematics involving the motion of particles and objects, right? Then it contains displacement, velocity, acceleration, time, and those concepts of motion, right? Okay. Now we'll read the question, right? Question 24. Particle P moves along a straight line that passes through the fixed point O. So there is a straight line like this, and it passes through a fixed point O. Right. Now this particle P moves. Let's say particle P somewhere here, and it moves like this, like this, like this, like this, like this, and okay. Then displacement of P from O. Displacement of this particle P from O, from this O, at time t is x. Then x is given by an equation, that is function given by a function of t 40 cube minus 2070 plus 8. That is the displacement function. What is displacement function? We will write it here. X equals 40 cube minus 2070 plus 8. This is the displacement function. Okay. Of the particle. Then motion of P reverses that point A. There's a point A somewhere here. Then this particle P comes like this, like this, like this, like this. And here what is the reverses? It comes to this point and it comes like this, like this, like this, like this, and from this point it was like this, reverse like this, and goes back. Right. Okay. Reverse that. Acceleration of P at A is A meters per second. Here acceleration is what? A meters per second square. That's the acceleration. Then find the value of A. They ask this acceleration value A. That is the value of acceleration at when the particle is at point A. That is the point of reverse in the direction, right, of motion, right. Then they say this particle reverses the direction. When a particle comes like this and on the same line it reverses, on the same line it comes like this, and on the same line it reverses. It first of all stops here and then it comes, because if it comes on one like this, one line, and it reverses on a different path like this, then no need of having no need of stopping. But when it moves on one line and it reverses on that line itself like this, here it's very temporarily it stops here. That is called instantaneously P rest here. When it turns, we're moving on a straight line, when it reverses, when a particle moves on a straight line and reverses, at the point of reversal, it comes to an instantaneous rest. That is the principle of motion of particles moving on straight lines, right? Then particle makes us instantaneous instantaneous rest. Rest means particle very, very briefly. Where it comes to a very, very brief, very, very instantaneous stop there. And then start the motion in the reverse direction, right? And motion backwards, right? Then whether a particle comes to a rest or instantaneous rest, its velocity is zero. Velocity is zero. Velocity is zero. Therefore, we will find the velocity function from this one. Displacement, then we'll important point is when P is at A, P has an instantaneous rest. Therefore, because it is a rest, therefore velocity of P at A is zero. Right, that is the principle. Okay, now we will start solving. Okay. Now here, so therefore we will calculate the velocity function from this one. So this is the velocity function from this one. Velocity. Then first of all, displacement is x equals 4t cube minus 27t plus 8. Then velocity is the differential coefficient of displacement. Therefore, dx over dt. Then equals what? Velocity v equals, we will differentiate this. If we differentiate this 3 times 4, you write 4 into 3. This coefficient is, and then you have, when there is a actual function of what we call set of terms, then each term must be when the function of addition and subtraction of terms, then we have to differentiate each term separately. Then this one is differentiated, this one separately differentiated, and this one is separately differentiated, right? And then 4 into 3 into t, you deduct 1 from the power, 3 minus 1, minus 10, 27, the power of t is 1. Then into t, here power t, 1 minus 1. Then here, then this is a constant. Differential coefficient of constant is 0 because there's no t term there. Okay. Now write here v equals what? 4 times 3, 12, t to the power 3 minus 1, 2, minus this one, 27 into 1 is 27, 1 minus 1 is 0, t 0, then this is 27 t 0. Then t to the power 0, then v equals 12 t squared minus, then here t to the power 0 is 1, then 0 power of anything is 1, therefore 27 into 1 is 27 itself, right? That is the velocity function, right? Now this is the velocity function. Then this velocity function, we know the velocity at this point is 0. When p is at a, p has an instantaneous rest. Velocity of p at a is 0. Then this one we can equate 0. Then 12t minus 27 equals 0. Then 12 t squared equals 27, then t squared equals 27 over 12. Then this one we can write 27 over 12, then 3 times 9, 3 times 4. And then you can write that 9 over 4. Then 9 over 4, then t equals, then you take square root here, then 9 over 4, because time is always a positive value. Therefore, we don't take the negative part of the square root, we take all the positive. Then t equals how much? This one, t equals square root of 9 is 3, square root of 4 is 2, 3 over 2, that means 1.5. 1.5. What are those? Time must be seconds. T is time t here should be seconds. Seconds here. T seconds. Seconds. Okay, t seconds. Therefore, here t equals 0 to t equals 1.5 t. T equals 1.5 t. Sorry. 1.5 second means sec. S 1.5. Yes, that is the time. That is the time when this the particle reverses at A. That is the time when particle reverses at A. Right. Okay. Then particle has taken 1.5 seconds to reach it. Okay. Okay. Then we ask the acceleration of that, and therefore we know the time when the particle is at A. Now we want to find the acceleration, then we will get the acceleration from this one here. Acceleration, then v equals velocity is how much? 12t squared minus 27. Then acceleration is the differential coefficient of velocity. Therefore, we differentiate this one, dv over dt. That is what acceleration equals are. Then 12 into 2 into t, 2 minus 1. Then this one here, differential coefficient of 27, that is constant c. Then it will be then A equals 24, 12 into 2, 24. T here 12, 2 minus 1, here power t, 1. Okay. Then A will be 24t. Then we have to find the acceleration when the particle reverses at A. We know the time at which the time that the particle has taken to reverse at A. So to find the acceleration of the particle at A, substitute the time that of the particle when it is at A, then that is A equals 24 into 1.5 seconds. Then it will be how much? 1.5 means 36. 36 meters per second square. So this is the answer. That A equals 36 meters per second square, right? Okay, that is all about that question. Have a nice time. We'll meet you in another interesting video. See you, bye.